Hello and welcome to Interaction Design Module 3 Tutorial 1. What are we going to be doing today? So as we move into Module 3, we want to be thinking about, it's kind of a summative moment for us, right? In Module 1, we had physical interactive circuits using copper tape and the LEDs, using physical interactions around us. In Module 2, we looked at web interactive sound, so digital sound using P5 specifically in the browser. And in Module 3, what we're going to be doing is combining these things. So we're going to have some kind of a physical interaction using a makey as a device, and that will provoke or trigger some kind of a web interaction. So the makey, we made sure that we were going to reuse the makey. It was a device you guys had gotten in first year. I don't know if it was described too much before, whether it's a microcontroller, and a microcontroller can sometimes be a bit confusing for people because it looks like it's on a circuit board, and therefore maybe it's some kind of a computer. It's not a computer. A microcontroller allows you to connect sort of sensors to a computer. So it's bridging the physical and the digital, and it allows basically like a physical interaction to become digital data, so interpreted as numbers by a computer. It connects to a computer by a USB. Some microcontrollers, like the Arduino, which is something that you'll use next year, you can connect its own battery, and it can be completely autonomous like a computer, but it's still really just sort of sensing things. The one working with the makey has to be connected by a USB, and that is because what the makey is actually doing is it's sending it's not sending a driver. It has a driver installed. If you don't know what a driver is, every device you plug in that uses a USB has some way of telling the computer what it is, so the computer knows how to use it, right? So if you plug a keyboard into your computer, it knows the difference between a wired keyboard and a wired mouse, for instance. That's what the driver does. It tells the computer what it is. The makey tells the computer it's a keyboard, and that's why it works so easily. So each connection of the makey sends a keyboard signal for a specific key, right? So there's arrow keys, there's a space bar, there's a mouse press button, and that's what that's doing, is it's basically telling the computer that that's what's happening when it happens. So the P5 interactions we're going to build are actually just going to be experimenting with this keystroke input, right? So if P5 responds to an arrow or a space bar or a mouse click, then when we do that with the makey, it will trigger the same exact interaction. So that way we can kind of build an experiment with the with P5 by itself, other than just making sure the makey works. We can just sort of experiment with P5 and then go and build some kind of a makey interaction so that it's connected. So these are not supposed to be disconnected things, but we should experiment with them so that we can come up with the best kind of devices and the best kind of P5 interactive sort of website that we can, or web sketch that we can. So it isn't that there's one that's better than another, it's the way they integrate, right? So it's the integration of this physical and digital interaction that really is the point of this. So whatever you do in P5 should have some reflective quality with the thing that you build with the makey. So the way we're going to do this is in tutorial 1, which is today, we're going to look at using P5 keystroke interaction. In tutorial 2, for next week, the we'll be looking at the makey interaction. So we'll look at how do we, design some interesting makey devices that we can use that allow us to then interact, knowing it's just going to have to be connected to the computer and then trigger those keystrokes, right? And then in tutorial 3, it's really going to be about integrating them. So tutorial 1, tutorial 2, it's all experimentation. What can you come up with? What are the different ideas that you have? And then in tutorial 3, it's going to be integrating them so that by the time it's done, it makes sense that the thing that you've built that's physical really somehow makes sense with the thing that you've built that's digital. So as we go forward, instead of it is really an awkward word to be sort of typing out over and over again. So we're just going to refer to the Makey Makey as the Makey Makey, MKY, MKY. All right. So for today, week 10, tutorial 1, we're looking at P5 keystroke interaction. First thing you need to do is connect your Makey Makey to your computer. You need to test and make sure that the wires are working, that the Makey Makey is connecting, because it's the first part of debugging any kind of physical computing is when you plug in your microcontroller, you test it just to make sure it works. So we're going to plug it in. We're going to use some of the code that's already been provided to you guys. The code that you're seeing here will be provided and uploaded, and right now you should have it with you. So what you're going to want to do is make sure you download that code, open up that tutorial 1 in Visual Studio Code. And then we're going to look at the code. So we're going to drop that down, and I'm going to pull up the code here. And you can see that I've got in the, maybe just I'll grab that to show you in the background. I've got the Makey Makey on one of my desk surfaces. I've got a keyboard here that has big light up keys so that you can kind of very easily see, and I'm using the arrow keys, the space bar, that kind of thing, and the Makey Makey is right over here. Right, you can see that it's working, and that's one thing to do. As soon as you plug the Makey Makey in, the light should go on. In order to sort of like test its most basic function, you need to make sure you're holding the ground, and then and I don't know if you can see that the light is going on there, but the light is going on there. So you can easily kind of confirm that, and we'll confirm it even more once we get the code actually running. So let's take a look. What does this code look like? So you can see that when you get it, there's obviously an index.html, and there are a total of 7 sketches here, right? And of these 7 sketches, a lot of them really just jump very quickly from one to the other. So you can see that we don't really have a CSS running, although once you we'll look at what we can play with the CSS by the time we get into the third tutorial. You can see there's really not much going here, right? Makey Makey P5 interface is the title. You can see that we're just pulling in, I do have a P5 sound going in here, because sound is absolutely one of the things you can experiment with. And I've got the DOM and the P5 min. Other than that, there's really nothing in here. It's really basic. So in sketch 1, sketch, we're connected to sketch. Let's take a look at sketch. So I've got a couple of variables. So I have val R, val G, and val B. So that's obviously like red, green, blue. I'm setting their, I'm declaring them, defining them, giving them 0 value. In the setup, it's just to create canvas. In the draw, you can see that I have a fill, and I'm using the RGB for each of those. That's really what fill is going to do. And I have a rectangle that's going to be, it should be half and half, but I'm finding that the display height is not really going the full display height. It's kind of funny the way it's running right now, but it is a 500 by 500 square box. In the key pressed function, right? So I have this key pressed function going on here. You can see that I have a bunch of if and if else statements going on. So if key code equals left arrow, value R equals 255, and value G and value B equals 0. So you have to reset it every time, or it isn't going to change those. So if the left arrow is clicked, it's going to be red. If the right arrow is clicked, it's going to be green. And if the up arrow is clicked, it's going to be blue. And if the down arrow, I believe that's going to be yellow. And if the space bar, so to have space bar, you leave a space between there. I think that might be pink. Oh, no, it isn't. That would be R. What is it? Oh, it's like a light blue. So this key pressed function, and then this mouse pressed function, you can see it's just changing to another color. I think this is the pink one. So you can see that out of this, we have 5 keys, right? 5 basic, wait a minute, 1, 2, 3, 4, 5. We have 6. We have the 6 different keys that are on the Makey Makey. And with those, we can change the color to a square. So let's take a look at that And where is it? There we go. That's the right one. Oh, and that's me clicking with the mouse, which of course here, that's what clicking the mouse will do. So let's see what happens when I click up. So the blue, I'll just do like this. You can kind of, really basic, right? Nothing surprising there. Now we of course want to test the same thing on the Makey Makey. So I'm going to ground it. Remember that the way the Makey Makey works, if it's been a while, let's just talk about this. Remember when we did the circuits and we had to have one connection coming out and one connection coming in, right? So we have the power coming in and the ground that's coming out. Remember we had to have specifically, you have to have those two separate tape pieces, and each side of the LED had to be connected to one or the other, but it was very specific. So the Makey Makey, the way it works is this whole bottom area here is the ground. It'll say earth right on there. In fact, I can maybe even just pull this up a little bit like this. You can tilt it that way. There we go. So what you need to do is you need to touch it, right? And then there we go. Now, if you don't touch it, then it's not going to do anything, right? Because you need to actually be grounded. So I'm going to hold that there. And now you can see how that works. And now, obviously, it works. So it's tested. So that's the first one. So let's go to the second one. So let's go to sketch 1. So you can see here we have a const move. So this is a variable. We're just making it a constant variable, okay? But it's just calling it move. We've given it a movement of 10. So it's going to basically move like 10 pixels. That's what that is. And then we've created a XY, let XY variables as well. Create canvas, no stroke. If you wanted a stroke around it, you could. And here we've just set the X and the Y. So we're just setting the X and Y to begin with in the setup. So it's half and half. So we'll just put whatever we're building in the middle of the canvas. Background is set to, I don't know what color that is. I think that's that blue color we were looking at. It could be whatever color. Fill is set to another blue color. The ellipse you can see is running. It's that X and the Y, right? So it'll start off taking the X and Y from here in the setup as it first draws it. And you can see that the ellipse is set to 200 by 200. Again, that's just the size. That's the location. Key pressed is still using the same idea. So if key code equals up, else if key code equals left arrow, it's just basically giving you each of those different arrow functions or arrow it's not a commit, a parameter, maybe, right? So specifically, it knows what up arrow is. These are known parts of the library, and that's why this, in fact, the way this whole thing works, and the reason why we're going through this is that you can use this, and then inside the curly bracket, whatever you put here is what it's going to do when you hit the up arrow. So what we're going to do is go through a series of different ways you could do this. First one was just looking at how you can do that with color. This one is going to be looking at, so if you take the Y, right, so if the key code equals up arrow, the Y is going to be minus equals move. So it's going to take that move variable and it's going to minus equals 10. Then this is going to be the left arrow is X minus equals 10. So each of these, that's what it's doing. It's basically just, remember, the move is an abstraction for that number. And there's nothing going on with the space key. You could actually take this right out. I've just kind of left it in. And again, there's nothing in the mouse press. These are both completely blank here. But I'm leaving them in so you can just see the structure, so that if you were to take this code and want to do something else with it, you could give it something there. You could have it randomly change the color of the ellipse or the size of it or anything else if you wanted to. These sizes, these could also be variables, right? Anyway, I digress. Let's pull this up. Now you can see that's there. I'm going to click into the browser window and test it again. You can see that that's moving up and down. And then let's come in here again, and I'll grab that, and there we go. And I do have it so that it only does it when I press it. It's not like it just starts going in that direction and then I have to move it or stop it, right? Which would be another way you could do this. You could easily turn this into, like, you can see if I hold it down, nothing happens. You actually need to like press it and release it. Right? Okay, that's the second sketch. Let's pull up the third one. Well, actually, I guess it'll be sketch 2, which is the third one. Oh, sorry. Let's go to sketch 2. Let's take a look. All right, so we got something different here. Now we have value z, x, y. So now instead of it being RGB, we're playing with these. Remember, these are just names that I've made up, right? Like these aren't. This does not mean anything. This does not mean like the way left arrow means something, right? So this is just a variable name, and we're starting it off by giving it a 0.0 to begin with. We have our create canvas, and you can see, look at that, we're using a WebGL. So if we're using WebGL, you know that we're using something that's 3D, right? Normal material. So if you remember going all the way back to first, would it be, I guess, first module from last term, we were looking at making P5 3D objects, and normal material was specifically one of the types of material that you can put onto a 3D object. You'll find normal material fits in with a lot of different 3D modeling that you might do. Specifically, this is how P5 applies a normal material. And what that normally means, it just has to do with how the color of the material looks, how it either takes shadows or light, and that kind of thing. Off the top of my head, I don't remember what a normal material is versus a Lambert material or a Phong material. I'd have to go back and take a look, like what it is that differentiates it. But there are different materials based on what you want to do. Our draw function, we have our background. Now we have a push pop. So everything that's happening within here is like a controlled space. We've talked about that before. And you can see that what we're doing is we're rotating the z-axis, rotating the x-axis, and rotating the y-axis. It's using this frame count. And you know what? I'm not actually super... I haven't looked into frame count specifically. My guess is only that because we are dealing with a rotation of something, that we're going through the draw and it's going to be looping as the frame count is running. I would actually recommend you do experiment a bit with that, because I didn't, right? Like I found different chunks of this code, experimented with it, and then just pulled it in and was playing with it. But I haven't pushed it too hard. I just wanted to get it put in place so that you guys could easily kind of get it and then go play with it. So that is a place to go and experiment with. You can see that down here, I've taken the box out, but there was a box. It's easy to see it with the torus, so I pulled in a torus. And that's basically it. Key pressed is very similar to the other ones, right? We're using the same key code equals up arrow that we're doing, but in this case we're taking that val z, and this is equals minus, and you can see it's very incremental. So there are places you can play with the increment of that. Just keep in mind that sort of the way I have the in this case, I don't know if the up and left and down and right even matters that much, which is which. So you might find that there are things that you can play with that make that matter more. And you can see that if there's a mouse pressed, I have added that, and specifically it's going to reset it to 0, 0, 0. All right, let's look at what that looks like. Oh, actually, you know what? Here, let me just... there we go. That's better. So now you can see we've got this three-dimensional object there. I'm going to click in the browser, and let's see. There we go. So I'm rotating it. So I can just rotate it in different directions. Now what it's not doing is lerping in between them, which would actually be better. So lerping would be like slowing down and then going in the other direction, which would be way better, you know? So, but that would also take building a function to do that. And this is just kind of showing you how you can use the arrow keys to play with it that way. Do the same thing. We'll kind of grab the makey and we'll... There we go. Okay. Anyway, just wanted to show you guys how now you can control a 3D object, which is pretty cool, right? Okay, back to the code. Let's go to sketch 3. And In Sketch 3, it's very similar. We've still got the XYZ. You can see this time, though, we have this cur camera variable, which is going to be the current camera. So think about that. Like, we're basically going to put a camera in our scene. So here, and you can see we've actually built the camera right into it, and the camera is running off of this value. Oh, look at that. There should be a 0 there. Interesting. So it's setting the X, Y, and Z at 0 plus 0 for now, right? So right in the middle. And then if you want to go, I would say go and look up camera if you want to see what the rest of these guys really do. It's kind of setting it right now as sort of the default camera position, but we want to access the default camera position and affect it using these variables, okay? Fill is set at 200, which means it'll be some kind of a gray, and rotate, we're changing the rotation of this plane. So this plane is a 500 by 500 square that'll help kind of see a bit of depth, right? Like that's what it'll allow us to do. There might be a shadow on it, I don't remember. So it's going to be a gray plane that our whatever our object is will allow it to, and in fact you can see it's the same torus pretty much, right? So we have the same exact method that's being used there, except in this case it's not changing the torus at all. So the torus doesn't have a variable attached to it, it's just doing some kind of a rotate. And then there's a key down function, and there's the key down function. So when the key down function is pressed, you can see that it's now changing this val y minus 5, val x minus 5, val y plus 5, runs through that, and those are right here. So this is going to control the camera. So let's take a look at that. Okay, I've clicked in it, so let's test it first. Oh, you can see it kind of... Alright, so now you can see if we get... It's definitely in sort of like a real clipping plane of the camera. So you can see there it is. It almost wouldn't hurt to like have it pull out a little more that way. And it could be that the space... There we go. If I pull out... There we go, right? So we can kind of control that camera view, and which is actually pretty smooth. It's pretty good. Let's play with it here. Great. Lots of fun. And then back and... Oh, maybe I didn't put... Oh, I see. Right. You have to actually click the mouse. It's funny, the space is actually... These ones keep on going. Like you just touch them and they keep on going, whereas the mouse key you have to keep pressing. Anyway, cool. So that one is camera control. So if you wanted to build a 3D space and control the camera using the Makey, you could do that with this one. Right? You can see how completely different each one is. Like they're all really different from the previous one, you know. I'm going to, or maybe I'll just move that out of the way a little bit. You can see enough there that this might be better if we were doing this. Let's go, there we go. Yeah, that way you can see that a bit better. Let's go to Sketch 4. So with Sketch 4, you can see that we still have the very similar current camera. We have our now have I can't remember if the background was in the last one. Was there a background there? Yeah, it was a background there. So still just a white background. Same plane. All of this is identical. So you can see that what's happening here, though, is it's actually changing the way that the current camera... Actually, let me take a look at that current camera move. Yeah, you can see here that it's just affecting the val y, val x. And in Sketch 4, you can see that it's actually going to be changing, using this key is down. So this is a slightly different one that we were doing. So this is creating sort of a nested function, right? So it's a key is down left arrow function inside this camera.move function. And you might say, well, where's that coming from? And do we have... Maybe it's able to move... Oh, no, sorry. Oh no, current camera dot move, and it's just setting it back to that location. So it's just setting the specific. All right, that's fine. Let's take a look at what makes this one different than the other one. We'll go live. And okay, here we go. So let's see what's different about this one. Wow, so this is really kind of controlling it really precisely. It's not very nuanced at all, but and it really does have to be one or the other. Move forward. We can still move back. We still have to click on it though. So it's definitely a mouse click. Was there a mouse click in there? Let me take a look. Mouse pressed, sorry. Okay. But anyway, another camera movement one. You can play with the two of them and look at the different ways that the nested function works compared to just changing the variable itself, or the value of the variable. Okay. Next we'll go to sketch 5. Okay, well, you know what? Sorry, let's look at sketch 5 first. Okay, so now you can see there's a whole lot going on here. I have a link on here, which is where I got the this idea from, right? And so I've taken basically most of their sketch and then gone in and added our a button in it so that we can access the microphone, or even just trigger. I did find that it mattered to have this on there to trigger the sound, and specifically. You can see that it's very similar to the stuff we were doing last module with the synthesize, right? So this is actually within that sort of, you can see there's a delay and a reverb. And we have the same button, the same old button we've been using. And now you can see there's a mouse clicked function, which is just going to be starting. I think it's starting and stopping the sound. We'll have to play it and just check on that. The mic is going on, but it's funny because it's not actually using the microphone directly for this one. But then we're using that if on. If you remember that we used this one, this is the if on that is here for this mouse pressed turn on. Here's the turn on function, and it's doing if on equals true. So on should be set to false. Let on, I'll just put here. On equals false, and then, or was it, let me see, if on, key down, nope, that would be it. That would be it. Now, I don't have anything running in the mouse pressed. I don't know if this would, because this is certainly the mouse clicked, which is affecting the button that's going to start it. So right now we're not doing anything in the mouse pressed itself. I don't know if that would affect things afterwards. Hard to say. Might have to play with that a bit. But it works. I know this works, so I'm not really too worried about it. But you may not want to do anything within the mouse pressed, or play with it and see if that does something to break it, right? You can see that there's in the on that we have this. Let's look. So we have this let the analyzer get level, let size. So we're mapping the amplitude. We're creating a variable called size that is mapping the amplitude, and then we're creating a variable called f that maps the amplitude. So it's mapping it on two different ranges, right? So you can see that one is the color. So fill is f. So we're taking that f here, and it's using the color is based on the amplitude, which is kind of cool. No stroke, so it's just an ellipse that is using, then the location is width, height, so it should be right in the center, and it's using size. If you see an ellipse and it only has one sort of third variable and it doesn't have a fourth variable, that means that this is going to be both. It's the same number for both width and height. So in this case, it's going to be mapping it based on this. So you can see, so when we're mapping, remember, it's going to take this, it's going to map the 0, 1 to 0 to 400. So 0 is to 0 and 1 is to 400. So it'll take this small thing of like a 1 and a 0 and it'll give it a massive range, right? And you'll see that the power of that is that instead of having something sort of pop from one to the next, it has a range. And then we have a key down function, which is the same function. We have this if key is down, and this is using that exact same method that we used in the last one. And this is going to be playing an octave. So you can see that each one is going to be, so you can see that it's a let octave equals 4, but then its polyplay is C plus octave. This is using the polysynth function, which is more complicated than things that we did with the sound in the last module. And if we go way up at the top here, that's basically why this is here. Like if you want to know more about the way this works, go look at his site, because I do not know enough about sound engineering to give that a better explanation than I'm going to here, which is basically that you can see that each one of these keystrokes is aligned to a different key. So this is C, this is D, this is E, this is G, and this is A. This is actually called the major pentatonic scale, and it is a 5 key. So penta is 5. This is a 5 key scale, all right? And let's both hear and see what that is like. And so now we're moving into a whole different realm for the project. This a bit so this way you can see both at the same time. Now keep in mind that this is the worst keyboard for this. Even though it's lit up, I hope that's easy enough for you guys to see. It's a mechanical keyboard, which means like you hear every press of that. So here, let's listen and watch what that's like now with just absolute silence. It's great. The reverb is just so beautiful. And so that is, and here's how I want to describe this. This is the 5th one. This is actually sort of the end of the of the sketches. The last sketch that we're going to look at is going to be, okay, what does experimenting with this look like? So I'm going to show you, based on this one, just some very, very simple sort of experimentation that I did with it. So we're just going to go to sketch 6. Let's jump down to sketch 6. And what you'll see is that, let me go all the way up. Sorry, you're going to see that I've added, so there's a color range that's been added. So I've basically combined some of the sketches. I believe this might be combining that bit of that first one or ideas around the first one. Although you can see that, to be fair, it's a random color kind of thing that it's doing. So not just changing color. There's a random color that it's doing here. And you can see that there's even, like, in the variables, I've created a let amount, start color, new color. So it's kind of the color it's at and the color it's changing to. The poly, this is all actually still the same. The poly with the delay and the reverb. Again, this is a great thing to dig into for this project if you want to. 100%, especially as we've kind of come off the other sound one. But if you're more interested in the movement ones, or you're more interested in the color ones, there's lots of ways to approach this project. Experiment with a bunch of them. That's obviously the button. None of this is different from the last sketch. What do we have here? So you can see in the background color. So there's a lerp color, which means that it's start color, new color. It's going to be changing color. And this smooth step is really what it's doing. This is a function, and the smooth step function is, it's just, or is it a full, I think it is, but it's not here. Oh no, there it is. There's the smooth step function, which is taking, and this is a function that I grabbed. I did not write this function, right? So what it's basically doing is it's blending from one color to another color. That's what it's doing, okay? And I've placed it in here with background, so you can see that it's its own function in the library, and all of this is inside of it, okay? So it's taking whatever the color is that lerp color is created. It's using start color and new color, and then the smooth step is actually the way that it's transitioning from one to the other. So I would say if you want to learn more about lerp color, this is in the reference, and you're going to want to go and take a look at that and see how you can play with it in a different way. You can see this amount, AMT, is right here, and it's plus equals this very low, like 0.001. So it's a very low incremental thing. We have an if statement that is if our amount is greater than or equals to 1, then do this, which is this start color equals new color. So this is like the mechanics of triggering what's happening right here, okay? But again, this whole little chunk is stuff that I've actually certainly applied to the background, but I pulled this out of some other interesting code that I had found. I can't remember if that's from the P5 website. It might actually be. We have our amp that we're analyzing, and then we can see we still have the same sort of size because it's still the ellipse. The ellipse is exactly the same as the other one. What's different here is there's a stroke, right? And the stroke is using that B color, G color, and R color. There's a stroke weight, so it's of 10, and again the fill. So whatever the background is, and then the stroke is, right? You can see that, and so the color of the ellipse, the stroke of the ellipse. Except you can see that it's the stroke of the ellipse, but it's slightly off of that. So it's taking whatever the number is for that, and it's offsetting it by 10, right? So that means that you will be able to see the ellipse, even though it's not just black, right? Basically what that's getting to. And it'll change color along with the rest of it. Key down, same key down function as before, except the difference here is it's actually also adjusting. So all I've done here is I've added in the colors as well. So every time the key is being pressed, it's changing whatever the variables are, or the values are of the R call, G call, B call. So this is going to both play the sound and affect the color. And all that did is really kind of pack this up quite a bit. Let's see what that looks like. That was a long way to explain what this is doing. You can see there's a little tiny ellipse in there. So we'll start off just by... Did you see the colors shifting? There you go. So hopefully that kind of gives you a little bit of an idea of where you can start to play with this, about mixing some of these things together, about the color with the sound, about the adjusting movement, all of these things, right? You can play with them in a 3D space and a 2D space. Lots of room for playing with this project. Our week 10 tutorial 1, P5 keyboard interaction form storming. Again, it's like we've done before, experimenting with the code. Play with the mechanical way the code works. Play with the aesthetic way the code looks. Follow your curiosity, even if it breaks the code. Save every version every time. Make sure you save those aha moments for your form storming grid. And start form storming.